Hey, welcome to Lessons with Mr. Clark. Today we will be learning about fractions. We'll be talking about the basics of fractions. So let's take a fraction here. Let's start with an easy one. Let's just start with 3 over 4. The 3 is in the numerator, the 4 is in the denominator. The numerator is on top, the denominator is on the bottom. Lots of ways to remember that. I remember Notre Dame, N over D. You can remember D starts with the word down. It's in the basement. Lots of ways you can do it. All right, so Notre Dame. Numerator is 3, the denominator is 4. What does a fraction mean? Well, fractions are division problems. You look at a division sign, looks like this. Look, it's a fraction. 3 on the top over 4. 3 divided by 4. Okay, so that's what fractions are. The hint I like to think about is I'm a big fan of pizza, so I think of fractions in terms of pizza. So if you have 3/4 of a pizza, you got your pizza here. You have 3/4, 3 out of 4 pizza slices. I also like basketball, so I like to think about it, and I'll use a lot of examples with shooting baskets with the basketball. So here's my artwork, here's my rim. I'm shooting baskets. If I make 3 out of 4 shots, that's pretty good. 3 in, and then 1 brick. 3 out of 4. All right, so those are a couple examples I'll be using throughout. All right, let's talk about equivalent fractions now. What are equivalent fractions? Equivalent fractions name the same amount, but they have different numerators and denominators. So, what are equivalent fractions? 2 or more fractions that are equivalent, that name the same number. That are the same. So let's say we deal with pizza. We have half a pizza here. That's the same as, if I divided it into fourths, be the same as 2/4. If I divided it into sixths, it'd be the same as 3/6. These are all equivalent fractions. Okay, so that's equivalent fractions. So in a special case, for this next one, let's say we have 2 over 2. If the numerator and denominator are the same, it's going to equal 1. Equivalent to that would be 3 over 3. 3 divided by 3 is 1. Equivalent to that would be 11 over 11, or 1082 over 1082. Those are all equivalent fractions that equal 1. Okay. In its simplest form, just the number 1 over 1. Even simpler, it's just the number 1. Okay, so to find an equivalent fractions, we can multiply or divide the numerator and denominator by the same number, something that equals 1. You know that. Anything times 1 is the same. So I could multiply or divide. Up here my example was a half. I can multiply that by 2 over 2, or 3 over 3, or 11 over 11. Okay, so let's do some examples. So let's do 5/8. I made 5 out of 8 shots in basketball. If I multiply the numerator and the denominator by 2, I would get 10/16. 5/8 is the same as 10/16. Okay, here's another way to write it. I do it this way most of the time. I'm going to multiply the numerator by 2 and the denominator by 2. Okay, let's do another one for 5/8. Let's this time multiply each by 3 over 3, which is 1. So 5 times 3 is 15. 8 times 3 is 24. These are equivalent fractions. Okay, sometimes you'll be trying to simplify or reduce your fraction. We want to put things in their simplest form. Okay, when we do that, we must divide. So far, my examples have been multiplying. We're going to divide by a common factor. Remember factoring? You should. Okay, so let's take the number 15 over 25. We could list all the factors of 15. We could list all the factors of 25, and we can divide them both by a common factor. To simplify it the most, or reduce it the most, we're finding the greatest common factor. Remember doing that? Okay. But right now, let's just find any common factor. What goes into 15 and 25? You're right, the number 5. So let's divide the top and bottom both by 5. 15 divided by 5 is 3. 25 divided by 5 is 5. We have 3/5. Is there a common factor that we can divide both these by? Well, you could divide them both by 1, but that won't get you anywhere. They're both prime numbers. That is your answer. Let's do another one. Let's do 16 over 24. Okay. Well, they're both even, so we could just start by dividing them both by 2. That's not our greatest common factor, but it's a common factor. 16 divided by 2 is 8. 24 divided by 2 is 12. We can keep going. That has reduced some, but we're not in our simplest form yet. What can we divide them both by? 2 again? Okay. I hear you. 8 divided by 2 is 4. 12 divided by 2 is 6. Still not our simplest form. We can still divide them both by 2. So that's 2 over 3. Now we are finally simplified. We have finally completely reduced. 16 over 24, reduced or simplified, is 2/3. Now, look what we did. We divided by 2, and then divided by 2, and then divided by 2. We could have just at the start divided by 8, our greatest common factor, and gotten there a lot quicker. Okay, let's talk about comparing fractions now. Okay, so I got an example over here off to the left side. We have 1/3 and 7/8. Okay, let's see if you can just use reasoning to find an answer. Use something that makes sense. And I've got 3 different ways to use reasoning to figure this out. Is any clearly bigger or smaller? And you can do this with a whole list of numbers too. Well, let's look at this. 1/3 or 7/8. Let's say you're eating a pizza. Would you rather have 1/3 of a pizza or 7/8 of a pizza? Clearly 7/8. That's almost a whole pizza. You just have a little bit left compared to just 1/3. So 7/8 is clearly bigger. Or if you're shooting shots, would you rather make 1 out of 3 shots or 7 out of 8 shots? 7 out of 8, for sure. So just use reasoning. Okay, second strategy. If the numerators are the same, compare the denominators. Okay, let's go back to basketball. Would you rather make 2 out of 5 shots or 2 out of 7 shots? You'd rather make 2/5 of your shots than 2/7. Once you got to 2 out of 5, you missed your last 2 to get to 2 out of 7. So 2/5. We're comparing denominators. If the numerators are both the same, the numerators in this case were both 2. Okay, what if the denominators are the same? Okay, now we're going to compare the numerators. Okay, let's go back to that basketball example. You shot 16 free throws each time. One time you made 12, the other time you made 14. You'd rather make 14 out of 16 than 12 out of 16. If the denominators are the same, you can do that. Okay. All right, so that's the first. Use reasoning. Second, if both denominators are different, find a common denominator. and change them to equivalent fractions. A lot of times you'll see me write the numbers vertically instead of horizontally because that's, I think, easier to see, especially with equivalent fractions. So 4/5 or 13/15, nothing just clearly stands out as being bigger or smaller. Different numerators, different denominators. Okay, so what is a common denominator we could use? Here we have 5, here we have 15. I could multiply them and get to 75. Let's use 15 as my common denominator. To get from 5 to 15, I'm multiplying by 3. So I'm going to multiply the numerator by 3. We get to 12/15. 13/15 is already there. Okay, so now that they're both equivalent fractions, we can go back and look at what we did on step 1. Denominators are the same. 12 out of 15 or 13 out of 15? 13 out of 15. Okay, let's do that again. 2/3 and 3/5. They're both a little bigger than half. Okay, common denominator. It doesn't have to be the least common denominator. It could be any common denominator. Okay, well, 3 and 5, we could list the multiples of 3 and list the multiples of 5. We would find that 15 works for both. Notice we did these both times 3 and those both times 5. So 9/15 and times 5 times 5, 10/15. So 2/3 equivalent fraction is 10/15. 3/5 equivalent fraction is 9/15. 10/15 is bigger, so 2/3 is bigger. 2/3 is greater than 3/5. Okay, and here now we have 4/12 or 2/5. Let's find a common denominator with 12 and 5. We can use any multiple. If we just multiply them together, we could get 60, 5 times 12. It might not be the least, but we know we can get there quick. So that's 24/60ths. And that's 20/60ths. Okay, now that they're both equivalent fractions, with a common denominator of 60, 24/60ths is bigger, so 2/5 is bigger. Okay. There are other strategies you could use for that, but we can always find common denominators. Okay. In conclusion, today we learned about fraction basics. Thanks for joining me. Hope you have a great day.